Okay, let's start to wire this thing up. Here are the batteries. I have them set that these two are one way, these two the opposite way, these two are one way, these two the opposite way. You can see from the red tape, these are positives here, and these are positives here, and these are negatives here, and these are negatives here. The reason I have that is how I'm going to do the series connection. So the two that are the same way are in parallel, and you can see this bar joins them in parallel. So these batteries are in parallel, these are in parallel, these are in parallel. And then we will make series connections between this pair and this pair and this pair and this pair. And then I'll have a wire which runs up the back and connects onto the top battery. And then this pair will series to this pair, which will series to this pair, and then this will be our main positive coming out here. So our main negative will be down there, and our main positive will come out here. And I'm putting the main negative at the bottom because on the back here, on your negative connection, there's actually a lot of things that connect to the negative connection. The BMS connects to the negative connection, my fuse will connect to the negative connection, and I have a shunt for the meter, which goes on the negative connection. So I have three things that all need to run through the negative connection. So I'm going to have the negative connection at the bottom so that the wire can come out here and run through the BMS, through the fuse, and through the shunt before it wakes its way up to wherever I'm going to put my inverter and the other things. But I kind of need the extra space from the bottom up for the negative connection. But let's get back to the front here. So let's make a couple series connections and we'll go from there. Now, since this is going to be negative and negative is at the back here, this will be my main negative at the back here. And then to do your series connections, you got to go from, negative to positive, positive to negative. So this is my main negative. So then its positive here needs to connect to the negative of the next battery in the series. So this is a series connection now joining the positive to the negative of the next pair of batteries. And I am using these wing nuts. I had mentioned these in an earlier video. These are awesome because now I don't have to stick a tool in here. If I try to put a socket in here or something to tighten nuts, I would definitely short out the batteries and end up melting something or damaging something. By using wing nuts, there's no risk of me shorting anything, and this battery is less than 30 volts, and the human skin doesn't conduct at less than 30 volts, so I can touch all the terminals I want, and I can't get a shock from this battery. So we're gonna put all the wing nuts on here, and you do not connect this negative with this positive. When you're doing series connections, there is only one connection between the series batteries. So that's the one connection, positive to negative, and then this positive will connect to this negative. Do not confuse how you wire series versus parallel. Okay, so that's good. Now since this series connection comes to this negative, now you need to go from the other side of the battery, the positive on that side now needs to connect to the negative of the next set of batteries. And we can put some more wing nuts on. And actually I shouldn't tighten these up too much, I still have to put balance wires on, so I need to think about that. But we'll come back and add the balance wires once we kind of get the battery sorted out. Yep. I like these wing nuts. The nice thing is I can just give them, I can't really over tighten them. I can only tighten them as tight as my hands go. So that's good. Okay, so this negative is connected to that positive. So now this is the negative. Now this is the positive of the next battery, which now needs to connect to the negative of the last battery on this row. Okay, that's good. So now electrically, these four pairs are in series, and this is actually a 12-volt battery right now. And then we're going to do it again at the top, and then we'll have two 12-volt batteries, and then we're going to use a wire which comes from the back to the top here, and that'll series up the two 12 volts and make our 24-volt battery. So next thing I need to do is take some measurements with wire, and I need to crimp together a nice 6-gauge power wire and join the back of this battery to the top of this battery. So that's what I'll do next. All right, let's make our 6-gauge connecting cable. Here it is. First thing I'm going to do is, I've roughly measured it to length. I'm going to cut off some of the insulation. Do this carefully because you don't want to cut too much of the copper strands. You want to just kind of get through the insulation without damaging the copper underneath. Takes a little bit of skill and some patience, but there we go. We're through, and I don't think I damaged one piece of copper. So let's do it again on the other side. Okay. Oh. Sorry about that. All right, that is done. Now here are some lugs that I ordered. These are 6-gauge lugs. This is 6-gauge copper. Let's get a couple lugs. And also we need to remember to put some heat shrink on. And so remember to put it on before you crimp. So let's put that on there. I see this paper wrapper. I'm going to tear that away. I don't want that in my... There we go. So I have double heat shrink on the battery. Okay, let's slide the lug on. Okay, that's good. And now we're going to use the crimper to crimp it. These manual crimpers are okay. The hydraulic ones are probably better, but they're pretty expensive. These manual ones are okay. It just takes a little while to sort of get things set up and you know, if you're doing sort of 6-gauge or 8-gauge or whatever, it's totally fine. It'll be hard to do like a 2-gauge or a 0-gauge with this hand crimper, but on something like this, this works just fine. As you can see, that is crimped. And let's pop this off and have a look at it. Not a bad crimp. Wish it wouldn't have flared out the wire out the side like that. But let's just check mechanically. It's on there. Yeah, mechanically it's tight. So I think that will do, and we will heat shrink it on with some heat shrink, and I'll do the other side. Okay, the power wire is made, and it goes from the negative at the back, comes up, and actually, no, it goes from the okay, yes, I thought I wired it wrong for a second, but it goes from the positive at the bottom rack up to the negative at the top rack, which is correct. And then we will continue our series connections across the top rack. Okay, all the series connections are made. Let's see if we have voltage. Or we should have about 28.5 volts, probably closer to 29 volts. Okay, so that is my positive over there. That is my negative over here. 28.5 volts. There you go. Perfect. So yeah, the series connections are made. So I think the thing I'm going to do next is I need to swing this around, and I need to work on the BMS location and the balance wire location, because all of that's kind of got to happen on the back side of this this battery. So I think that's what we'll do next. Okay, I have done most of the wiring. You can see the balance cables are on there on all the batteries. That is the main BMS lead attached to the negative and heading out to the back. Here's the top side. You can see that wire joins the bottom battery to the top, comes across here, and there's all the balance wires are on there. I just haven't yet taken off my main positive. Let's spin it around and show you the back. So here's the BMS. You can see that the lead goes in and connects on the negative, and here's the BMS, and this will be our next, this will be the negative that goes into the shunt and the fuse and stuff like that. These are all the balance wires coming from the top pack and the bottom pack and going into my Wago blocks. And then the BMS balance wires go into the Wago blocks, and this external balance wire goes into the Wago blocks. And then that allows me to just plug in my ISDT whenever I want, or an iCharger if I need to do a top balance or anything like that. I can just plug in with this external connection at any time and I'm good to go. And there's all the batteries. And I put a little piece of Velcro on there just so I can mount it on there and keep an eye on things. And same thing with the iCharger and that. I can put a little Velcro on it and check on it. So next I need to put a positive and negative up to these two bus bars. Okay, slight change of plans on the wiring. I forgot. I need these bus bars to run through the BMS. I can't take power directly off the battery because then these won't run through the BMS, and then technically I could run the battery below its minimum if I left the 12-volt circuits on. So the negative has been rerun over to here, which is on the negative side. And then I also, another reason to run it over here is you want the shunt to measure how much energy the 12-volt circuit is pulling. So I have the negative for the 12-volt circuit running over to the shunt, and then any energy will pass through the shunt, and the shunt will measure how much energy we're pulling. Here's my 150 amp fuse, my 100 amp daily BMS. I also decided to use pretty beefy wires on these bus bars, not because the 12-volt circuit needs it, but because over there is my solar charge controller. I'm going to run the wiring for the solar charge controller right down just to these two bus bars. And then the incoming solar in turn can run over to the through to the batteries through these bus bars. And so since I'm going to be bringing in 400 watts of solar, these need to be pretty beefy. So these are pure copper, pretty beefy, I think like 14 gauge wire. So that's the new plan. And but anyways, the 12-volt circuit is working and running through that fuse and the BMS and the shunt, so that's good. Yeah, so that's that, and I'll just slowly keep knocking away. This, by the way, this is actually a brand new solar charge controller. You can see I have my other one over there. I decided to buy another one because I actually don't want to take down my lithium-ion Powerwall. I'm going to keep that one and have this one as a secondary one, and I want them both to be able to charge off my solar. So I'll parallel the incoming solar between the two charge controllers, and I won't use them at the same time, but if one battery needs to be topped up, I will turn on that particular solar charge controller and top up the battery with that charge controller. So yeah, each Powerwall will have its own solar charge controller and its own inverter. You can see I happen to have two big 24-volt inverters. That's my better one, so that one I will move to this Powerwall. But this is actually a pretty good Chinese one, but I've tested it, it's pretty solid. So this one will then replace that one and be on the lithium-ion Powerwall, so I'll have both Powerwalls functional. Okay, so I decided to actually mount my inverter on here because I was kind of running the wire and shooting for a moving target. I didn't really know where I was shooting for. So now I've put the inverter on there, and so now the negative can run across, down, and attach to the inverter. Let me take you mobile for a second. You can see the inverter is on the side. The whole idea of this is that I want this to be completely portable and rolling around and have my power available. And this is my 2,500 watt WZ-RLB inverter. This thing's excellent. All right, I am done wiring the Powerwall. It is complete. I haven't even yet programmed the solar charge controller or really tested anything, but I have finished doing the wiring. I might move some things around, some things, my OCD might cause me to move some things around, but the basics of everything are here and done. And let me show you around. I must, first off the gate, I love using these stainless steel wing nuts. what a genius idea, because, you know, no tool, I don't have to put any tools in the rack, I don't accidentally short anything, you know, this is the first time I built something and I haven't sparked something, so that's a win by my standards. So, you know, and everything's nice and tight. So yeah, I think wing nuts definitely the way to go here. So let's talk about how this thing is wired. Let's start on the top here. This is our main breaker. The battery positive comes into it, and then it goes out there, and this is the main switch to bring everything up, and everything comes off this. The 12-volt circuits, everything, the solar, everything, you know, runs through this, so that when this is broken, nothing will run. You should also know, by the way, that this is a marine grade breaker, and I like the marine grade breakers because they're usually rated for 48 volts, and this is a 29 volt system, so this is great. But one more thing, that there's actually normally a battery side and a load side marked on these breakers, and on this breaker, the top here is the battery side and the bottom is the load side. So you want to make sure that the current's traveling in the right direction for this breaker. But anyway, so, you know, this is the main breaker, and you can see everything powers up when I throw that breaker. I literally haven't even programmed the solar charge controller. I have to do that put in the settings later, but and then I can break the main breaker with that. This over here is the incoming PV. So when I'm hooked into my solar, I will close this breaker, and that will allow solar to come in through the charge controller and then back out into the battery. So this is my breaker for the incoming solar, and this is the main breaker for the battery. Let's bring you around the back, where the magic happens, as they say. So here is the main power breaker, and that just goes straight on into my 2,500 watt inverter. Okay, so the power just travels right into the inverter. I do tap a second power wire off this breaker, and that runs down to the bus bar, and that's also where I send the incoming PV into this bus bar, so that the incoming PV can run back into the battery through the breaker. So that's the positive side of things. Most of the work is on the negative side of things. The negative side is down here, and this BMS connects directly to the top of the battery, and the negative comes in here, comes out of the BMS through a fuse, from the fuse into the shunt, and from the shunt into the inverter. Yeah, so the negative runs straight across and into the inverter. I tap a second negative off here, and that runs up to the bus bars to provide the negative for the bus bars. And by tapping it off there on the other side of the shunt, the power meter, which actually I forgot to wire, but the power meter will be able to actually read how much energy also runs, you know, through the bus bars and into, say, the 12-volt circuits. And it will also reverse read when the solar comes in. The solar will go into the bus bar and down back through the shunt and into the battery, and so the meter will read reverse current as the incoming solar comes in. I've already shown you all the balance wires and stuff like that in the 12-volt circuit. This is the incoming PV, my incoming solar. I've wired on a XT60, and I've where my main solar comes into the garage, I've also teed in another XT60 on the incoming solar, so I can just plug this into the incoming solar whenever I want. And the incoming solar then comes up here. The positive gets split and broken by the breaker, and then the negative goes directly into the solar charge controller. And then that's why, like I said, I can use this breaker to turn on and off the solar, because the positive is broken by this breaker. Yeah, and then here's my solar charge controller. Like I said, I still got to program it. We'll move over here quickly. You can just see I've mounted the inverter on the side, and I can just plug plugs in as needed. And yeah, I mean that's the whole, you know, portable Powerwall right there. And the whole idea was that I could roll it around my garage and plug it into solar and unplug it from solar and have my inverter wherever I want it. And yeah, I think I've sort of achieved that. I will say this thing is heavy. It's well over 200 pounds. We know the batteries alone are 180 something pounds. Plus this is a stout inverter, plus the wiring. Yeah, so I mean this is well over 200 pounds, but I put it on some good, you know, dolly wheels, and yeah, I think it's I'm pretty happy with how it came out, and I can just park this in the corner of my garage and plug it into the solar, and it can just sit there and I can use it whenever I need to. So yeah, I think that's the basics of this done. I still need to put on the meter and program the solar charge controller, but you know, that's probably for another video.